This meeting is being recorded. Excellent. So let's look at, so hopefully you can see that residential estimating overview. And I will be sending this out as a handout. So we're just going to go through this pretty directly. So if you've got a little tiny screen, you're going to have a hard time. But this came out of another book. So the source it came out of is at the end of this thing, I believe. Yeah, Estimating for Residential Construction by David Pratt. So not a brand new book. There's some web pages in here, some recommended resources. So that NAHB, that's the National Association of Home Builders. So what are we trying to do? Why are we estimating? So it says a building cost estimate is an attempt to determine the likely cost of some building work before the work is done. So we're trying to predict the future. And, you know, we also need to know why we're doing the estimate, because there's a lot of different reasons for preparing estimates. But we're talking primarily about residential construction. So in residential construction, it says the type of estimate used depends upon the residential market served by the builder preparing the estimate. Nature of the contract. So we need to understand the contract because that establishes the rules under which we're going to have to work. And the purpose of the estimate. So before you start any estimating, the very first question you should ask yourself is, why am I doing this? And what's the purpose? What's the goal of the estimate? If you don't have know what the goal is, then there's no sense probably in proceeding at that point. So for residential builders, typically we have spec builders, custom home builders, and then multi-unit building types. Remodeling is a specialty within that. And if you have questions on remodeling, we can talk about it. What I do know is remodeling always costs more money. There are almost always surprises. There are other issues that you may have to deal with. Lead paint and asbestos being two common ones. Trying to work around somebody that wants to stay in their house, maybe another one. Most people don't want to move out. So that all impacts the cost. Contracts. They list a bunch of different ones here. Stipulated lump sum. And so if you're doing a stipulated lump sum, the contractor's assuming most of the risk. And you're just telling them, you're not giving them a breakdown. You're just going to say, I'm going to build you a house with a 2-car garage for X number of dollars. And hopefully you've got the right lump. So firm price is a little bit different because under lump sum, you can still have change orders and modifications. Firm price is where before you start work, you actually give them a price and say, it's going to cost this much. And you don't have change orders built into it. You're pretty much guaranteeing a price. So that has even more risk for the builder. Variable price. And you could be looking at different levels of quality, for example, or different options. And so additive, we talked about additive bid items or deductive bid items. That could be variable price. Cost plus, which for residential is illegal in California, but that puts most of the risk on the client because the contractor is guaranteed to get paid for what they've done. Percentage fee. So where you're just, you come up with a cost and you're going to get paid a percentage of whatever that cost is. So that would be a percentage fee. Sometimes the owners don't like those because there's no incentive to control costs, because if you're getting paid a percentage of the total cost, if you double the price, then you should be getting double the fee. And so there's not a a lot of incentive for the contractor to try and save money. Fixed fee, again, that's shifting some of the risk back to the contractor, because no matter how much it's going to cost, contractor gets the same amount of money. Variable fee, unit price, so those are all different types of contracts, and they influence how you prepare your estimate. So any questions on any of those? Yay, nay? So Mo, did I hear a question? You have a question, Omar? Hello? Okay. So then we get to the heart of it. Besides the contract, why are we doing the estimate in the first place? And so, determining the feasibility of the project, we're not going to do a detailed takeoff. What we're trying to do is find out if the owner's budget and our expectation of project costs are anywhere close, and if they're not, there's no sense in going forward because the project's not feasible. If we determine that the budget allowed and the expected cost, based on what information we have, look to be somewhat similar, then we can move forward and get into more detail. Calculating an approximate price of the project is what we're doing sometimes, but that may be looking at options and methods. And so again, we may be looking at big elements, roof, walls, floor, concrete foundation, wood foundation, things of that nature. So trying to figure out a sales price. And how much do we charge for sales? Anybody have an idea?
20%.
As much as possible, right? Whatever the market will bear. So when prices are going up very quickly, it wasn't that long ago, prices have flattened out a little bit, but it wasn't that long ago when, somebody was trying to sell a house, people would bid above what the asking price was, and there really wasn't any direct correlation between what it costs to make something and what you're going to sell it for. So in some cases, you can't sell it. You may take a bath on it, but normally you want to figure out what your sales price is, and 20% may be good, but it depends on how much money you're spending trying to get the sale. So calculating bid prices. So sometimes we're doing estimates. We're trying to look at what the subs are doing, and we're trying to get a general idea of where we think the subs should be. So when their bids come in, we have some basis for estimating. And then that last one is where we're really getting into the nitty-gritty of things, where we're trying to determine project budgets for cost control purposes. We're going to use it for construction management. What we're saying here is that when the projects are just an idea, we're just doing those feasibility. So we talked about this before. It's called blue sky estimating or conceptual estimating. And again, if you can make accurate predictions with very little information, then people are willing to pay you money. They'll come talk to you. So I don't know if any of you with this coronavirus thing, since a lot of people are unemployed, you can set up your own psychic hotline. And if you're good at predicting the future, you can set up an estimating psychic hotline. So sometimes we're just looking at the estimated cost of a component or element of a building compared with the perceived value of the element. So we're doing a value analysis. I don't know if any of you do any value engineering. I can buy a car. What do I want that car to do? If I just want to go from point A to point B, I could get a Lamborghini to do it, and I'd look pretty stylish, but I'd be spending a ton of money. I could go buy myself a used beat up car that's will reliably get me there. I could spend a lot less money. I'm still going to get there. If all I'm concerned about is getting there, then probably the cheap beat up car. If there are other issues involved, like I have a need to be very stylish, then maybe I do need the Lamborghini. So we talked about setting home prices. So cost control, in order to do accurate cost control, we need an accurate budget. In order to do a detailed budget, we need to do a detailed takeoff. And preliminary estimates, though, we can do price per unit. If I'm going to build a house, I know they're all about the same size. I just say, okay, X number of dollars. Price per unit area, often we're estimating on a square foot basis. And I think here in San Diego, kind of, average level, they're looking at construction costs about 150 bucks a square foot. Or if you're going to buy a house here in San Diego, I think it's around 250 because of the land prices a square foot. Over in El Paso, my daughter was buying a house. Most of the housing over there was running about $95, $100 a square foot. Other places, it may be more. If you go to San Francisco, it's going to be a lot more. If you go to probably Alabama or someplace in the deep south, in most places, it'll be a lot cheaper. We can do price per unit volume, so they can have a cubic foot price. That's sometimes used, or we can do it by assembly, where we're going to spend X number of dollars for the roof, and the roof is going to include framing, roofing, insulation, drywall. And so again, for estimates where we don't have a lot of information, a lot of times we'll do it by assembly because it can be done quickly and without spending a huge amount of money, just guessing what we're going to do. So what we've been working on is the quantity takeoff, but detailed estimates include 6 distinct procedures. So quantity takeoff, or if you're working in Canada or England, they call this quantity survey. And so they actually have a job description called quantity surveyor. So that's the quantity takeoff. So in order to come up with a cost and time, we need to know how much work there is. We need to know what the productivity is. And from that, we can estimate how much time it's going to take. So once we've done the takeoff, we typically, like I say, have a bunch of messy sheets. We have to recap the quantity. We have to come up with the material price, the labor price, and any equipment prices associated with that. And so even on a residential job like these, there's a certain amount of things that just get lost, broken, used up that we have to account for also. We have to price the general expenses. So that's kind of the job overhead. Do we need a trailer? Do we need a phone? Do we need a security fence? Do we have to have meetings once a week with the owner? Do we have to have meetings once a day with the owner? So those are general expenses. And then when we're all done with that, we have to summarize, look at our overhead, and add some sort of a markup to make sure that we're getting the money that we want. So if we find out we can't earn the markup, the profit that we want, then we should probably go do something else, unless There is an old saying, if you want to make a small fortune in construction building, that the way to do it is to start with a large fortune and then go to work. And you can lose a little money on each job until you're broke. So, but not what we're trying to do. So again, as part of the process, detailed construction
Sorry,
estimates.
guys.
Hello? Do you have a question? Okay. Detailed construction estimates, we're going to use those hopefully to generate bills of material that list the quantities of all the materials that we need to build the project. And so this is one of the reasons for doing the detailed takeoffs is everything that you forget or don't have a list for are things that probably won't get ordered and are going to cost you more money if you have to get them at the last minute or make an extra trip. Much easier to have a detailed list of everything that you need, place the order, have it delivered, than to have to go pick up a whole bunch of odds and ends one at a time. Architects and designers, usually, well, often, they're not particularly experienced in either ordering materials, doing quantity takeoffs, or cost estimating. So, but they create the designs for new building and renovation projects, drawings and specs. And we don't have a detailed set of specifications, but specifications is, good specs are hard to write. They're even rarer to find associated with the job. Many of the offices, when they go to put together a set of specifications, they try and find an old job that had a set of specs, and then they'll just copy those old specs. They may update one or two things, but they really, most designers don't truly understand material specs. And one of the reasons I'm a little more familiar with the materials is because at the County of San Diego, I was the materials engineer for the Department of Public Works. And it always surprised me that contractors, designers, architects often don't really understand the specification choices that they've made. Just because it takes time. It takes time and effort to get involved. So we talked about the plans, and we have some plans, and you know, the big problems get to be, again, buried in those general conditions. Quite often you have to prepare shop drawings, you have to submit samples, you have to provide sketches of various things, and those become part of the construction documents that you're responsible for. The paperwork, there's a lot of paperwork, and if your contract requires you to document or show what you did or why you did it, then your overhead costs are going to be quite a bit more. So, soils reports, I don't know if we've talked about soils reports, but getting out of the ground is almost always a problem. Most people don't have X-ray vision. If we have a soils report on a lot, maybe they drilled somewhere between 1 and 6 holes in the ground. Those holes are typically 6 to 8 inches in diameter. They go down maybe 20 feet or to rock, or what they call refusal. So what we've looked at, say we had a 5,000 square foot lot, is we've looked at 5 holes about a half a foot in diameter, and we have based all of our design decisions on that little bit of testing and what we found in those particular holes. So quite often there are what we call change conditions, and those may come out as change orders later, become problems. sometimes people are, have I mentioned that people are cheap? Yeah, so people are cheap. So a lot of times you go, well, I don't want to spend that kind of money. Can't you just do something cheap and then come out and maybe look at it when we dug the foundation? Well, the foundation only goes down a foot to 2 feet. So there could be something a foot below the foundation that's a problem, a big pile of trash or something that might compress. And, you know, there's always a trade-off between certainty and, uh, like I say, being cheap. And so most people opt to be cheap, saying, we've built lots of places. We haven't had many problems. So I think it'll be okay now.
How much does a soils report normally cost? Is it like $2,000?
No, I would say a cheap one, $3,500 to $5,000 typically.
Ouch. Okay.
You know, that's not that much time. If you know, there's somebody has to go do some research, they have to meet with the client, they got to put stuff together. So, I don't know, you got, let's say you got 40 hours in a soils report. So somebody's got to type it up, you're running some lab tests. So 40 hours doesn't sound like a lot. So you're probably paying an average of 100 to 200 bucks an hour for that, right? So 40 times 100 is 4,000. 40 times 200 is 8,000.
Okay.
And so people opt not to do that. Now, sometimes the building department will come back and say, you know, we know there's some sort of problem in the area. You're going to have to do a soils report. Or the inspector comes out, you're in the process of trying to get a foundation inspection and says, those big cracks in the ground, that's expansive soil. We need you to go get a geotechnical report for that. So it stops your job. Plus, you're going to have to do some extra stuff. So getting out of the ground. Now, on the other hand, the contractor may come back and file a claim for what's called a changed condition and say, oh, you told me everything was going to be fine. Now we've got all this new information from a geotechnical report, or in some cases, the information in the geotechnical report, because they just looked at 4 or 5 little spots or 2 or 3 little spots on the lot, and maybe they didn't find water, but where they're digging, they go down a couple feet and they find a bunch of water, and now they've got to do something about the water in the trenches, and that can get expensive. If you're going to dewater, to go to the Regional Water Quality Control Board, if you can't put it in a public sewer, it's going to cost you $30,000 to $60,000 to get hire a hydrogeologist and figure out whether or not you can pump that water out and what you have to do with it. At one time, there was an exemption. If you can make an arrangement with the local sewering agency and put groundwater into the public sewer, there's a nominal charge for that, but you're not going to have to spend all that money. And last time I worked with the water board on one of those, it was 3 to 6 months to get permission for them to complete their review. So getting out of the ground is always a problem. So here they talk about the site visit. And again, this is an investment in the estimator or the estimating or the construction company's time. Somebody has to physically go out there, take a look, understand what they're looking at, identify potential problems related to the site. So sometimes that's soils. And I was working on a job, working with an engineer, and he wanted to cut the road down about 10 feet for somebody's driveway. And I said, I think that's going to be extremely expensive because you got a lot of rock on this site. And they looked at me and said, well, what makes you think there's rock? And I said, those big granite outcroppings coming out of the ground, that makes me think if you could see that above ground, below ground is probably worse. And they ignored me, of course. decided to proceed along. Last time I heard, they had abandoned the project. They'd spent a bunch of money, got a bunch of equipment out there, and found out there was indeed a big shelf of granite. Uh, Started at the surface and went down, and so it blew the budget for the entire project, and they had to abandon it. So that's one thing you're looking for. Another is looking for access. Can you get in and out of the site? And some places are fine when it's dry, but I've worked on jobs where the concrete truck came out after a rain like we had last night and sinks up to its axle or rolls over. And that can be a bit of a problem. You can have power lines that don't provide adequate clearance if you need a little crane or something. So, I mean, you may have drainage facilities that you have to deal with. There may be paving issues. So lots of problems only become evident after you do a little bit of research. And usually you have to look at the legal descriptions and look for easements, and there's a whole bunch of things that you may need to look at. So. And so that kind of puts a little bit of that, I think, in perspective. But the most important thing is, why are you doing the estimate? So that's the first question you need to ask. If it's just blue sky, we're not going to do a takeoff. We just want to know about how big, and does it make a difference whether you do 8-foot ceilings or 10-foot ceilings? Yay or nay? Yeah. Because the higher you get off the ground, the lower productivity is. And also you've got 25% more surface area for the walls going from a 8-foot ceiling to a 10-foot ceiling. And you'd be surprised at how much wall surface area there is in a typical house. So does it make a difference whether you use tile or whether you use comp shingles? Yeah, tile is generally 2 to 3 times as much as composition shingle, although it's heavier, so you're going to need more structure. Although there are designer composition shingles that are very pricey. How about a copper roof? Think that's cheap?
Nope.
No, that's very expensive. And you can't just get anybody to put on a copper roof typically. You need somebody who's experienced. So, you know, for those preliminary estimates, that's kind of what you're looking at, because if people blow the budget at the very beginning, you've got big problems. So I always tell people, figure out all the finishes you want, and then see if you have enough money left over to build enough structure that you can stick that stuff on. Because usually they've blown the budget with the finishes and the appliances. So if I do say a 1,500 square foot house, and I want to put in a $15,000 Viking stove in the kitchen, that's $10 a square foot. Just for the stove, for the whole house. And I know people that spend $100,000 or more just for the kitchen. You know, appliances, cabinets. Same thing in the bathroom. You can spend as much as you want in the bathroom. How much granite, how much marble, how much, those gold-plated fixtures. I noticed they're getting popular again on the Do It To Yourself channel. So in terms of where you need to pay some attention, you know, rough plumbing for a tub filler is pretty similar in most cases from tub to tub. But then when we get to the actual fixtures, I can spend a little or I can spend a tremendous amount. I can spend as much as you can imagine on custom features. So that's what we're always looking at. And quite frankly, most residential plans have absolutely uh, no real good specification for the fixtures. So contractor will come back and they'll just specify white, American Standard, maybe Kohler, Delta, whatever they think is appropriate for the job, or in many cases, they'll give an allowance. So let's say we're going to build a house and we give the owner a $10,000 allowance for kitchen appliances. Is that a lot of money for kitchen appliances? If they buy cheap ones, yeah, it's probably fine. But if they want, a Sub-Zero refrigerator, those are about $5,000 or $6,000. Viking stove or something similar, 5,000 to $10,000. They want a pizza oven. And I've had a couple people want to put pizza ovens in the house. So pizza oven, most of them aren't even listed, aren't approved to go into a residential setting. They're only approved for commercial installations because they generate so much heat. So you have to do a bunch of special stuff. But anyway, I'm going to send you a copy of this and I'll ask a few questions on it. But the number one thing before starting any kind of estimate is, what am I going to use the estimate for? And if you don't know what you're going to use the estimate for, then I don't know how you can even start doing an estimate. So this class, though, focuses on quantity takeoff, because in order to start coming up with how much work and how much that work is going to cost, somebody has to do a detailed breakdown at some point. But if all you're going to do is conceptual estimating, you're not going to be doing any of this stuff. You're just going to be looking at, have some very general parameters. So what we're looking at is fairly small. So I don't know if that helps, hurts. We're talking about providing a little more structure. So I think I can get rid of that. There you are. And we can look at, let's see if I can get my IPEVO up. So we'll go, any questions? Anybody still awake? Well,
Here.
okay.
I'm still awake.
I appreciate that.
I'm awake.
Excellent.
Have we done like a total cost for like the foundation of the first house yet?
I don't think so. I will put together a price breakdown for that, and then you can see if you agree or disagree.
Okay, it'd be nice to know what the cost was to have like a number.
Okay. Yeah, I'll have to sit down and work on that based on the quantities, and you have to make some assumptions too.
Okay.
Let me see, what was I trying to do here? Still not quite. Okay, can you see any of this? I've got a different screen up. Can you see that? What are you seeing currently?
Your face.
My face. Sorry about that. Yeah, just a minute. I'll get that something here squared away. Let me see. So we're looking at my face. So let me get back to here. Oops, wrong thing. I gotta move some things around a bit. Okay, what are you seeing now? Are you still seeing my face?
No.
Okay. Are you seeing a sheet of paper?
Yes.
Yes.
Hand? So we did have this board feet of second floor framing, so I don't know if everybody's done that. So we're gonna look a little bit at that. Also, I brought this into class. And I'll put together a couple more little handout things from this, but this is organized in a very similar way to your book. But this is the standard estimating practice for the American Society of Professional Estimators. Okay, can you see this sheet?
Yep.
Okay, and hopefully it says, let me get this thing out of the, I got something else floating on my screen if I can move it. Maybe there. And I will make a copy of this and send it out too. This lag is starting to bother me a little bit. But this is board feet of second floor framing. So this is a calculation that is associated with that other sheet I gave you. So, so you see A there, determine the size of the floor joist. So our floor joists are, if we look at the plans, anybody look at those plans?
Yeah.
So if you look at the plans, we have 2x12s at 16 inches on center. So board feet per lineal foot, there's a table in your book. But what we do is take the nominal cross-sectional area, 2x12, divide by 12, and that gives us 2 board feet per lineal foot. So next thing we're trying to calculate is total board feet of the floor joist.
Is that your handwriting?
No, are you kidding me?
Sorry, I was gonna say that's pretty awesome.
It is pretty awesome. This is Robert Wong. And Robert Wong has the best hand lettering of anybody I know.
Yeah, it's pretty cool.
That looks like it was done with a machine. So he has the best, so he had beautiful drafting. So I draw, but I am somewhat envious of his skill when it comes to lettering, but he uses a straight edge and I'm in a hurry. I get paid by the hour. So anyway, so this is our floor plan, the little schematic. So, you know, right here is that stair area.
Mm-hmm.
And he's broken it up into zones, right? We've got the 14 feet 4 inch, 13 feet 4 inch, 14 feet 4 inch, 18 feet going the other direction, and then we have that little stair tower. And so he's broken this up into 4 zones of floor framing. Zone 1 is just a little piece over there near the stairs. Zone 2, 3, and 4, part of the main floor. So, any questions on that draw? Other than how come I can't draw like that? So somebody else like to point out that my drawing sucks.
That's ignoring the beams that are in like zone 2 and zone 4,
Yeah, we're
right?
just looking at the floor framing now. So typically what we'll do is we'll do the start with the big stuff, and then we'll come back and look at the individual beams.
Okay.
Things that we might look at in addition with the individual beams. If they're flush beams, they're going to have hangers on them. If they're drop beams, then we run the floor joist over the top and we don't have the hardware associated with it. But the other things that may come up is if we're going over a wall, we may have a lap if we're breaking these up into small pieces. And so the code normally calls for a 6-inch lap or a 1-foot lap if you're lapping them over a wall, and that impacts the total span. So anyway, this is for our house, and I haven't checked these numbers in detail, but I will make a copy of this and send it to you. And so I will get that done tomorrow because that works for me.
Can you send it to our personal emails, Larry, like you
Yes,
always been doing?
I'm emailing, and I will eventually be posting to
Canvas? I hate
Canvas.
Canvas.
But right now, a lot of people are still having problems with Canvas. So I'm emailing things. I have also posted, I think the last class or the class before that, maybe two, to YouTube. So that's what I get to do late at night is take these recorded sessions and post them to YouTube in case you want to go back.
Thank you.
And if you have people that are bothering you, you can make them sit down and watch it and they'll leave. So it has that use too. So up here at the top, and again, you see that there's a couple things you should know. What this is missing is if you're doing a takeoff sheet like this, it should have a date on it. Because sometimes addenda get issued, or perhaps there's a change order, and you need to go back and see if it affects the work you've already done. It does have a sheet number, so this shows sheet 2 of 4 for this particular takeoff. Normally, I like to have a job name and what the takeoff is for on there. But you see that we're first looking at zone 1. So that's that little 5-foot by 10-foot length of floor. So spacing 1.333 feet. And if it was me, I would not use 1.333. Why? That's 16 inches. That's a repeating decimal. So 1.33 is close enough for me. I don't think that the degree of precision warrants the 3 decimal places, but that's okay. Span of the joist is 5 feet. Now the problem though is what? When we buy those joists, how long are they actually going to be?
They're going to be full length.
Well, we'll either buy 6-footers because they don't sell 5-footers, or we'll buy 10-footers and cut them in half.
Right.
So those are our options. Exactly what I'm going to do at the moment, I don't know. But we have number of joists, length of the floor or the distance over which we're spreading the joist out, which is 10 feet, divided by the spacing plus 1. So we come up with the 10 foot divided by 1.33 feet per joist. And I like to put the units in there, plus 1 joist. That gives us the 8.5. They're rounding up to 9. Total board feet, number of joists, times the board feet per lineal feet. Here says times the span, and they come up with 90 board feet. So what I would be assuming in this case is, right, if I'm ordering or if I'm buying, that we're using 10 footers and cutting them in half, because if I'm using 6 footers, or if I'm going to order the individual joists, I'm going to have to order 6 feet and cut them to length. So, because we can't buy them in 5-foot length unless we special order. Now zone 2. And again, where'd my sheet of paper go? My other sheet. Oh yeah. So zone 2. It's over here on the right. And so that's what this next calculation is for. And we have number of joists, so where the joists span top to bottom of the rectangle. They're being spread out over the 14.33 feet. And again, like I said, I probably wouldn't use the 333, but hey. So number of joists, the 14.33 feet divided by the spacing plus 1, 11.75. Round up to the next even joist, we got 12 joists. Then if you're looking for the total board feet of the floor joist, be 12 times 2 board feet per lineal foot times 18 lineal feet. Says 432 board feet. So, and again, this is an exercise just for computing how many board feet there are. Normally on a project like this, we would just figure out the length of the joist, the quality of the material. Is this Doug fir larch number 2, number 1, select structural? So we need to know the specifications of the material and the lengths. And so we just pay a price per each, but that per each price would be based on the board foot. So normally this isn't a calculation I would send off to the lumber company. They just want to know how long, what kind of wood, and how many. So any questions on this little calculation? Yay?
No.
Nay? Okay, good. So now we're looking at zone 3. So floor framing, again, 18. This is that center section. So spacing, span of the joist, number of joists, total board feet. So same as the little area we did before, and then we have the zone 4. And here's the calculation for that. Again, I'm not sure why they're breaking the joists, but they are, according to this picture. So again, what you're trying to do is do a takeoff on how you think you're going to build it. So here they're showing the short joist near the top, and we've got longer joists down below. So, and that's why they're counting the lap. They're showing a 1 foot lap over that interior bearing wall. So number of joists, board footage calculations, and then they're counting up, coming up with a total for all of the zones. Now, does anybody spot anything odd or irregular about this? Help me out.
There's no water heater.
Okay, there's no water heater. We've got that part. Doing it the way we just did it, we're gonna count two joists here, because when we break it up into zones like that, we're gonna have one extra joist between zone 3 and 4. And we'll have one extra joist between zone 3 and 2, because we have counted that edge joist twice in our calculations. We calculated it once for zone 2 and once for zone 3. And then at the boundary between zone 3 and zone 4, we've also counted that joist twice. So at the left edge of zone 3 and the right edge of zone 4, we have counted that joist twice. Any questions on that? Yay, nay?
That's helpful to see.
Okay. Well, I was trying to take some of the feedback and incorporate it.
And we're getting a copy of this on our emails, right?
Yeah, you will be getting a copy of this.
Okay.
So, and you can also go back and look at the video later if you want, because that will be posted too. So I'm not sure why I'm having, there we go. So, the total area square feet of the second floor framing, which we're probably going to need to do for plywood or OSB takeoff. And so we have the 18 by 42 plus the 5 by 10. So we get a total square footage, about 806 square feet. Last time we were talking about those board foot per square foot values on page 74 of the text. And so that's what they're showing here. Let me see if I can.
So we're doing the same with the concrete.
Yeah, we're
And
using a different method. So this is a quicker, right? Let's say all we want to know is a general idea. We're just looking at the floor itself, and we're not going to order anything, but we're trying to do just a quick estimate based on preliminary plans. We can say, yeah, we're going to have 2 by 12 floor joists. We can look in the book. So if we look on page 74 of your text, we can see that normally 2 by 12, 16 inches on center is about 2.05 board feet per square feet. And we can come up with a total based on that too.
with the floor, we're just doing the joists or the beams too, or just
Right
or
now,
just-
we're just doing the floor. We haven't done the beams yet.
Oh, okay.
So
What was the board foot cost that, I missed that last lecture?
we didn't have a board foot cost there.
Okay,
Now I sent you, hopefully you got that thing I sent you, I think after our last class. I think it was 5 sheets out of the cost estimating book. You can say no, that's okay.
I do not remember that one.
Okay, well, maybe I didn't send it, but I will. I'll go back and double check. Anyway, those 5 pages we went over in class that had the cost data in it, there's some price per board foot. So that was at, as I remember, it was $860.05 per 1,000 board feet. And so, for example, if we had 2,065 board feet, I've got a calculator here, I think.
Yeah, we got the pages in the email.
Yeah, I thought I did, but like I said, I'll double check. So here we've got, let's see if I can turn this on. Maybe. There we go. 2065. I'm not going to worry about the 0.38 times 860.05 divided by 1,000 board feet. So that's about how much the lumber would cost. It's about, and what does that look like? That looks like American independence all over again, 1776. So now what else would we have to pay in addition to that? Would we have to pay tax on that?
10% too, right?
Yeah, so you'd have tax, which depending on where you buy it, it's probably somewhere between, it's around 9%. 8.75%. I think it's 9.25% in El Cajon, but
Hmm.
1.09. Now we're up to 1935. So you see, if you forget the tax, we already lost about 180 bucks. And then, do we get it for free? Or are they going to charge us to deliver it? So we'd also
It's
have
free.
some
For that
delivery.
amount.
But, so that's how we would get a quick price. But if all we did was this calculation, we wouldn't know how many joists we need. We wouldn't know what lengths they were. And so from a project management or from a detail, if we're doing the work ourselves, that's not going to help us too much with the job, planning the job. But if all we're trying to do is get a quick price to see if we're in the ballpark or to check our subs price, if they tell us it's costing a certain amount of money, this is probably fine. If we're somewhere in the ballpark, we'd probably say okay. Now on this calculation, we're also using right here, that's a waste factor. Right, that's that. And again, I wouldn't use 25%. I would go 1.25 because that's what 25% is. But that's how they got to the 2065. So if you don't allow for waste, right, we're going to be short about 25%. And that's where we start getting eaten alive with our construction cost. If you miss 25% on your material cost, we've got a lot of problems when it comes time to charge somebody. So that is, I think, that cost. So that takes care of the second floor framing. Now in your book, and I'll make a copy of this too. but I think some of this information is in your book. There's a little bit of a time lag when I put these up. So over on the left, somewhere, right there, those are the nominal sizes. So B is the width. If you look above, you've got some pictures and they show you the B times H. And they tell you how many board feet per lineal foot there is in different sized boards. Now I know 2 by 6 is 12 divided by 12. That's going to be a board foot per foot. 2 by 12, 2 board feet per feet. So normally if I'm using these for estimating tools, I'll verify a couple of them myself. So cross-sectional area of a 6 by 8. 6 by 8 is 48, divided by 12 is 4. And so if you look right here, you will see the 4 board feet per lineal foot. So that particular column for different size boards, they've already done that calculation for you, so you can just look them up. So I'll send you a copy of that. If I had a faster computer, okay, it's a little crooked. And again, if you look at the top upper left-hand corner, framing material rules of thumb. This is from page 73 and 74 of your book. So they have stud size. And 2 by 4s and 2 by 6s, they have spacing. So 12 inches on center. And on the far right column there, they have the board feet per square foot. And so that's another way of coming up with an estimate where you look at the height of the wall, the size of the studs, the amount of top plate and bottom plate, blocking if you have it, and then you can come up with a rough board feet per square foot. And again, if all you're trying to do is get a general idea of how much lumber is going in the building, you can do that, but it is not going to help you when it comes time to order because you won't have made that calculation. But again, if your goal was just to get a general idea of how much lumber you need, so you can come up with a ballpark price for something, you can do that much more quickly than doing a detailed takeoff. And the little column there on the right, that's also out of your book. And that's for floor and ceiling framing. And so if you look down at the bottom, right here, 2 by 12, 16 inches on center. Here's that 2.05 board feet per square foot for the floor frame. And that's where that number came from for that calculation that we were looking at, that 2.05. Excellent. So wall framing. And again, if you want, you know, if you have a BIM model and it is drawn and you've drawn all the studs in there, you can count them. You can count every piece of lumber if you have a complete BIM model. But there's always going to be a waste factor. It's usually fairly high for studs. See, sometimes we have to block when we get stud spaces of 10 feet or more, you're required to put mid-height blocking in there. Usually that's not shown on the plans because that's a code requirement and they expect the contractor to know the code. And so and we have here at the window, you can see that while we don't have full height studs where the opening is, at the side of the opening, we've had to put in an extra trimmer, which means we've cut a stud down for that header. So usually you just ignore the openings unless they're very large and figure that you're going to use studs as if there were no holes in that wall. Double top light. So any questions on that picture? Yay, nay? Anybody still with me? Maybe.
Yes, we're here.
Oh, okay. I think you're all at a bar having a party somewhere.
Yeah.
Probably all sitting side by side, enjoying yourselves. So,
That's not allowed, Larry.
oh, yeah, I know.
We're gonna get citations now.
Yeah, well, that's what I heard. So, and so, if we had a 24-foot long wall, here's the little example. 24 feet. We're trying to find the number of studs. We divide that 24 by 1.33 feet per stud. I would not use 1.333. So that's lineal feet per stud. Plus one stud to complete the end of the wall, you'd have 19 studs. At the corner, we're going to add a couple studs to the corners and wall intersections because those are built up typically. We might have some posts, but we'd have to look at the plans. Again, if all we're trying to do is get a general idea of how much lumber we're going to need, we can use that board feet per square foot, come up with a number, see what they're charged, what the 1,000 board foot price of studs are, and come up with a material cost. But we do not have a list of what we need. We just have a number, a quantity that we can use for getting quick cost estimates. So any questions on that sheet? Yay, nay?
No questions.
Okay, that's good. And I can send you a copy of this too. Though I think this is probably somewhere in the book, and I have to go back and take a look. As an engineer, I use these three columns: the area, the section modulus, and the moment of inertia. So the cross-sectional area is used for shear calculations. Section modulus is used for bending or for strength calculations. And the moment of inertia is used for stiffness or deflection calculations. But you will notice, depending on the size of these things, over in the far right-hand column, they have calculated the board feet per lineal foot. And I'm sure you can get a database or an app that does all of this too. But this goes into some pretty big timbers. So if you want to order an 8x18, is that a big beam? Normally not readily stocked. So normally they don't stock anything larger than an 8x16 at the lumber yards. So typically, anything larger than that becomes a special order. And special orders, normally you have to pay for when?
Upfront.
Upfront, when you order. 8 by 24, most of the time, when I see people using some of these great big beams, they're doing it for architectural effect. And there are a couple of places where that sell used lumber. So a lot of these big timbers come out of old barns or old bridges, old railroad trestles. So, anyway, any questions on this particular sheet? I'll send that to you.
No, thank you.
Okay, let's get that to you. And I guess I can send this to you too. I think this is out of your book, isn't it? Basic framing elements. Now this one has a truss roof. And so there's some terminology that you need to use. And I passed this around in class, I believe, at one time. You can see it's a brand new book by that computer monitor. But I have a number of these construction dictionaries because there's lots of terms that I'm not sure about when I talk to other people, and so often I have to look these things up. And there's an engineering term. We were just talking about bending stresses, right? I give you a little something in there. And if you're an architect and you're going to take an architectural exam, they may ask you questions about this stuff, which is the extrados and intrados. So all of the terminology for a arch. Anyway. Okay, any other questions?
No.
Let me see. We got to get rid of this. Get rid of that. Okay, can you see me again? Sorry about that. So was this better or worse than the last time?
I feel it was the same.
The same. The same. We're supposed to be making progress here.
Little
Killing.
better.
So, okay, I'll be sending some things out. I'm going to let you go a tiny bit early today, but you can provide me some feedback. We were looking for a little more structure. So if I'm getting closer, tell me, but really in terms of adjusting my aim and providing what you feel like we need to be getting to you, I need some feedback from you. So
Okay.
Otherwise it's like a construction job where somebody comes in, explains what they want, and then says, everybody get that? And everybody shakes their head, yes. Yeah,
And
we
then everything goes,
understand. And then
Yes, yes.
as soon as that person is gone, Then they start looking at their buddies going, what the hell was that all about? So. All right.
Have a
Looks
good
like you got
night.
help there. So I'm going to stop recording at this point.